Can everybody see this?
Yeah.
Perfect. Okay, so I'm really happy to talk to everyone today, and really happy to have Nick as my co-presenter today. We're talking about context effects, mental representation, and I'll be talking about the limits of revealed preference in in the context of all of these things. Um, so what I'll be talking about today briefly is basically showing some concrete evidence of how context shapes the mental representation of how people view their informational environment and their choice environment, and how distortions in those representations will affect behavior and affect choices in a very predictable way. Like if you can recover the mental representation, you can do a really good job in actually predicting people's choices. The implications of this is that you can't just look at revealed preference in the way that we typically do in economics, where we say, like, look, here's what the choices that people make. We know the informational environment. We plug that informational environment into our models, look at people's choices and estimate people's preferences. If people's perceptions of their information environment is actually not the informational environment that they're facing, then there's going to be an identification problem in the style of Chunk-Bansky, which is he's been talking about that for a while. Um, I'd like to kind of think about next. I'm going to talk about briefly about how we like to think about context effects and nudges as something that governments and policymakers do, but in fact, many firms do this. And if I was to kind of like put two buckets of whether it's the private sector or the public sector that's using quote unquote nudges, I would put 90% in the private sector and 10% on the public sector. Even though this is not something that gets a lot of attention in the literature, but there's millions and millions of dollars being spent on these sorts of things of how context affects decision making. Um, as Alberto had mentioned, my recent work has been in AI, so I wanted to kind of start talking about what does AI mean for these sorts of things. And one of the things that comes out of some of my more recent research is that as more and more kind of economic transactions become being done by AI agents, the sort of nudges and context effects are going to become, well, as I'll show you, a lot less relevant for the sort of outcomes that actual people have, because these AI agents are just not prone to context. So there is obviously room for these sorts of things on other dimensions, but as far as like, what people are consuming or on different platforms, what they're shopping for and things like that, the sorts of context effects that firms have been studying and policymakers have been studying, if people are using their personal AI agents to make these choices, these sorts of context effects are going to become less relevant. And I hope at the end of the talk, we can talk about the sort of implications for nudging, welfare analysis, and other things that are really important for economists and cognitive scientists. Okay, so let me show you what I mean by context. So here's a question, and this is a project joined with Aislinn Boren, Michael Annenhauer, Josh Hasher, and Martin Weber, who Martin Weber is probably a friend of the audience. He's been doing this work for decades. Um, so which asset would you choose? So there are two assets, A and B. Each of them have a state-dependent outcome. So in each of these states, one of them is going to be chosen. Depending on the asset that you selected, you're going to get a payout. So if you chose asset A, and situation four, the state four was realized, you would get, 60, about a little under 60 cents. If you chose asset B, you would get 76 cents. As you could see from this graph, asset B mostly dominates asset A, except for this one state. In state 11, asset B does a lot worse. So the question is, which would you choose? So kind of think about it for a second. Um, Once you've kind of mentally made your choice, the big reveal is that the underlying marginal distributions of these assets are actually exactly the same. So each of these assets actually delivers the same exact expected value. And if you do independent draws, they're going to lead to the same distributions of outcomes. The marginal distributions are exactly the same. Each asset has the same probability of delivering the exact same. So without kind of thinking about mental representation and context effects, actually every single model, including things like prospect theory, expected utility theory, noise models that Bernanke and other folks and Mike Woodford have been working on, all of these models make the prediction that people should be completely indifferent between these assets. But what does context have to do about it? Well, Context has to do with attention and memory and how these sorts of cognitive constraints impact the way that people represent their informational environment, and then ultimately how they make decisions in that information environment. So even though these models that we're used to in behavioral economics are making the prediction that people should not have a preference, models of attention from cognitive psychology, models of memory, although not here yet, will make a strict prediction that actually people will prefer asset A in this sort of environment, despite the fact that they have the same marginal distribution. Why? Well, you can't attend to all of the states. There's 11 states, and essentially attention is drawn to deviations from these local norms. So the state, and this is eye tracking data from the same paper, basically you can see that people attend to the state with the largest deviation and they overweight the state in their mental representation. And I'll show you data in a few slides. How can you change the context? Well, people aren't always exposed to information simultaneously. You can change the context by giving them the exact same information sequentially. So think of like a price chart versus which gives all of the information at the same time versus just seeing the returns of an asset. You can give people the exact same information just sequentially. In one state, asset A does better than asset B, and all the other states, you give them all of these situations sequentially. So present the exact same information. At the time of choice, people have been exposed to the exact same information on what is the distribution of outcomes for each asset. And then you ask them what they choose. Well, again, if you don't take these sorts of cognitive constraints into account, our models would predict that people will have no strict preference between the two. But if you think about models of memory, what's going to actually happen is that because there's only one state where asset A did better than asset B, there's a chance that people will forget that state and people will actually prefer asset B because that's the asset that does better most of the time. So what this says is that you could take these cognitive constraints of attention and memory, and what they would predict is that despite the fact that these assets are exactly the same as far as their marginal distribution, you will get in one context people preferring strictly asset B, and in the other context, they will strictly prefer asset. So the question that this sort of literature tries to think about more broadly is, what problem do people actually solve? So the typical assumption is that the information people are given is what they use to form their beliefs and make their choices. And this assumption implicitly and sometimes explicitly underpins the entire revealed preference approach. But going back very long ago, before 1973, you can go back all the way to the early 1900s, cognitive psychologists have been talking about the fact that people's representationals of their environment do not match the actual information environment. So Weber-like effects, for example, is a type of this argument. So what this means is to recover preferences and to think about welfare, you need to actually recover the representations that people think that they're facing as far as what informational environment they're in. And as I mentioned before, this is not a new point even in economics. So you have Steiner and Stewart from 2016 talking about distorted mental representations. And then even before that, Chuck Mancy has been talking about the fact that you can't really do revealed preference if you don't know people's beliefs about the information. Basically, the reason is that when you're trying to, if people have partial information in this case, he's not talking about the behavioral context effects literature. If people have partial information, you need to know what that partial information looks like in order to identify preferences and then later do welfare analysis. So with that said, let me give you some data on this. I made some arguments, but let's see what people actually do. So basically, we have around 800 people who went through the exact experiment that I just put you through. So some people saw the chart, the experiment on the left, where everybody got exposed to simultaneous information about all of the returns from the assets. And then half of the people got exposed to sequential information, the exact same sequential information, state by state. And then at the end, we elicited their beliefs. The beliefs is essentially what is the expected value of each asset and the bin distribution of outcomes. So we elicit beliefs twice. So therefore, we can elicit people's representations of their informational environment. And then we ask them to make a choice between these assets where they could also indicate indifference. Any questions so far?
It was good.
Okay, so the predictions is that this context effect will make the decision makers representation will favor the unlikely outperforming asset A in the simultaneous information, the one that usually underperforms, but in one state outperforms by a lot. When the same exact information is given sequentially, that's going to reverse, and people are actually going to favor the frequently outperforming asset, which usually does better, but in one state does worse because again they forget that state. These choices are going to be supported by the elicited mental representations where they think the unlikely outperforming asset, asset A, actually has a higher expected value when the information is presented simultaneously, and the reverse will be true when the same information is presented sequentially. So as a first piece of evidence, these are the representations. This is the difference in expected value between the assets. So a positive amount, people think that asset B, the frequently outperforming asset, has a higher expected value. Again, 0 is the correct answer, right? So there's no like sort of, there is an actual correct answer here. This is not like choice where, you could come up with different models to validate their choice behavior. The expected value is known and it's an objective number, and the difference should be 0. They have the exact same expected. So the fact that people on average think that asset B has a higher expected value in the sequential treatment is a mistake because there is a given expected value and it goes in a specific direction. In the simultaneous treatment, they're also making a mistake, but in the exact opposite direction. Now they think that asset A has a higher expected. So again, same information, same marginal distributions, correct answer, and people are distorted in different directions depending on the context that they have their information. Choices follow the distortions of the mental representations. This is a very large effect. Almost 85% of people prefer the frequently outperforming asset when given the information sequentially, and people prefer the unlikely outperforming asset A, which usually does worse except for that one state where it does better when given all that information simultaneously. This is a 40 percentage point gap in choices for assets with the exact same marginal distribution. So, and in the paper, which you can find on my website called Mental Models of Information, we have an illustrative framework, and basically the illustrative framework has inputs, which is the objective informational environment. Those inputs get distorted through these attention and memory constraints. We generate a mental representation, and then you take that mental representation and then you evaluate it with a model like expected utility or prospect theory or these sorts of evaluative models. So what you have in economic models is you have these decision-making models, which include prospect theory, which include expected utility theory. But what's kind of taken as given are people's beliefs about the informational environment that they're facing. Typically, we just take that as the objective informational environment. The argument that we're making in this paper is that you can't really do that. In fact, when you elicit people's representations, expected utility theory completely rationalizes the evidence. So if we didn't have representations, we would basically take all of the distortions and choices and map those onto preferences. That's typically what's done in economics. That's kind of where some of the original behavioral economics models came from. What we show here is when you elicit people's representations, preferences can be represented pretty well with just standard expected utility theory, but the distortion is really coming from their beliefs. We have an illustrative framework in the paper. I'm going to go through this quickly. We basically kind of use the standard sort of salience models out there in cognitive psychology to think about limited attention. And then we use the standard sort of memory models to think about what gets forgotten and the likelihood of getting forgotten. This ultimately gets us to the final sort of framework where you have pies, which are the objective probabilities, being replaced by pi hats, which are the subjective mental representations. And then you have X's, which are the objective outcomes of each lottery, replaced with chi's, which are the remembered outcomes. In the case where all of the information is given simultaneously, the chi's fully map onto X's because there's nothing to misremember. In the case where people don't have any distortions, the pi hats correspond directly to pi's. And the goal of the exercise in the paper, which there's a lot of data in the paper, I don't have time to go through it now, is to kind of basically map these two objects to what actually happens. So here's some a few tests of these mechanisms. So is the effect really about salience channel attention? We actually look at eye tracking data, as I mentioned before. We take this graph and we show what people look at, for how long. You can actually use this sort of technique on the internet. So you can run prolific experiments by calibrating people's webcams and seeing what they look at. When you do that, you see that people overwhelmingly look at this outcome right in the bottom right corner. Uh, and then when you actually take that data and see, given what they attend to, what do their choices look like? You see that people who attend to the unlikely state are much more likely to choose asset A. So their attention predicts their choices. Obviously, this is not a causal effect. This is just correlating attention with choices. And it seems like attention is highly correlated with choices. Now, we can do the same exercise with causality. What we can do is take the experiment that I showed you before, the sort of graph that I showed you before, and remove the salience bias. Now, we're not removing salience. Salience is just a property of the informational environment. Salience bias means that one asset is systematically getting more attention than the other, which leads us to a directional prediction. What we can do is just take the same graph and jumble it. So the graph contains the exact same information as we had before, but now state 11 before, which is like the one where asset A underperformed, asset A outperformed asset B. Now that state is not so salient. And you can measure this with eye tracking. It's not so salient. So that predicts that the sort of difference in choices and representations is going to be mitigated. We could also manipulate memory directly. This is even simpler. We could just ask people in the sequential environment to write down the outcomes. So there's no scope for biased memory. And basically, what you see in these two treatments, the entire effect of biased representations goes away. They're no longer thinking that either asset has a higher expected value, and choices do no longer differ between the two conditions. So what this suggests to me, and I hope you agree, is that we really should be thinking about Mansky all over the place. Mansky has a wonderful econometrical paper in 2004 showing that with partial information, when there's uncertainty, many preference beliefs pair rationalize the same choices. So therefore, when you want to recover preferences and do welfare analysis, you need people's actual mental representations of, and he calls it just beliefs. You need to elicit beliefs when doing economics. The same exact logic basically translates to cognitive constraints. Many preference or representations pair rationalize the same data, so therefore you need to pin down representations in order to pin down preferences. Otherwise, essentially, what the typical approach in economics is, you have a people doing a lottery task, take those probabilities, put them directly into your structural model, and then you take any bias and map it on directly to preferences. So you get all of the bias being captured by preferences and no bias being by assumption being captured by representations. There's a really nice paper by Corinne Rosen, Geoffroy de Klippel, and Pietro Ottoleva, and others, basically making a similar argument in 2025. Once you eliminate these representational distortions, the choices reveal preferences. So I've shown you some evidence for context effects, and a lot of the kind of attention in economics and related disciplines like behavioral science, a lot of the attention about nudges and context effects has been on the public sector side. So nudge units, nudges more generally, that you can use these sorts of context effects to get people's behavior to be aligned with their kind of long run self, or whatever you want to call the normative welfare criteria. But if you look at the actual spending and the sort of like day-to-day interactions that people have with platforms, the internet, and how they're buying products, how they're kind of interacting with different entities in the market, especially in digital spaces, these sorts of nudges are being used a lot. There's millions of dollars being spent by companies like Meta and Amazon in order to influence what people buy, what they look at more, how they resubscribe, how they subscribe, and things like that. Things like defaults, pre-selection, the attraction effect, all of these sorts of things that we've documented in behavioral science and behavioral economics are being used very, very heavily by firms. And what that means is that, when we're thinking about nudging and nudging as an effective policy tool, we should also be thinking about nudging as an effective policy tool for firms to potentially get people, further away from their long run self, as well as the policy sphere, which is doing kind of the opposite. So that's to say that there's not really a neutral context. Every choice environment carries some sort of representational consequence. It might not have a systematic bias, but there's always going to be a representation. And so welfare analysis, both on the public and the private side, should be taking these representations into account. So enter AI. So we've been talking about humans this entire time, but some of the work that I've been more recently doing is seeing how many transactions that are currently being done in digital spaces are now being completely offloaded to AI. So, and there's been a lot of every single day almost, there's a new partnership between Walmart and OpenAI, Anthropic, and things like that, looking at how agents actually operate in the market space. It's a prediction of many people, including myself, is that where many, if not all, economic transactions will soon be offloaded to AI agents rather than the individuals. Namely, that people will have their own AI agent, or will it be interacting with the platform's AI agent when actually selecting between options? Behavioral economics, we've spent 50 years studying how humans choose in markets. So the question is, what happens when LLMs replace people in markets? So this is a project joint with Leonard Bernstein and Brian Jabarian, who's my postdoc. Basically, what we're looking at is that conceptually, online platforms will build for human attention, where salience, defaults, all of these sorts of things are really relevant. There's whole departments at business schools, such as my own, devoted to kind of thinking about human decision making as it applies to consumer choice directly. So the question is, when the buyer on the other end is an agent, do these techniques still work? Is the psychology of consumer choice still useful in the way that it's being done now? Now, obviously, there's going to be what ends up happening if it's not used. If AI agents are not subject to these sorts of biases, the psychology just moves up a layer. It doesn't disappear. Now the psychology is going to be how people interact with our AI agents, how they give their preferences to the AI agent, like that. So psychology doesn't disappear. It just moves somewhere else. So what we did is, just as an illustrative example, something fairly simple. We just took the most popular and most robust effects in behavioral science, marketing, and behavioral economics that have been shown to move people's. These are context effects to move people's preferences in one direction or another. And what we showed with a bunch of humans and AI agents is, in the first experiment, we just had we had choices between lotteries where we had some lotteries be dominated. So nobody should select these choices. When no context effects were explicitly used, only 1.7% of people chose it. When you used context effects, this went up to 8.6%, which was a very significant difference in our sample. So basically, these techniques do work. Some of them work really well. So for example, the are you sure kind of like testing uncertainty actually pushed humans 20%. Percentage points, 10 times the control rate. But when you have AI agents make those choices, all of that goes to zero. Not a single one of these techniques works with AI. In the study two, we went away from lotteries. We took Itamar Simonson's 1989 rent versus commute paradigm, where you have different apartments and the apartments differ based on the amount that they cost to rent or the commute to your job. This is a classic multi-attribute choice a puzzle. We used conjoint analysis to elicit people's underlying preferences between these two dimensions, and then we gave people choices between these apartments, either in a control treatment or one where we used kind of these context effects to try to move people's preferences, and then match their preferences to what they ended up choosing. So what you find is that people's preferences are less aligned in the context effect condition compared to the control. But importantly, as I said, there is no neutral context. When you give your preferences to an AI agent, even in the control treatment, the AI agent was more likely to match people's underlying preferences. And it was not those choices did not move with context effects at all. Um, which suggests that AI agents, again, in these sorts of contexts, really do eliminate these sorts of effects. Um, what we think what we think about how do we think about this project is, I think, human psychology and behavioral economics is alive and well. It just needs to potentially move to a different layer in thinking about how people interact with their agents, how they interact with AI, and all of these sorts of things. And obviously, this is with a big question mark in the extent to which this happens in the first place. People have forecasts, I have forecasts, but we need to be in the real world and actually be tracking the extent to which this actually matters. Um, so what we are seeing even now, like today, is that the rise of these AI first firms, where you have firms, marketing firms, which are not at all thinking about human psychology. They're thinking about advertising to AI agents using engineering tricks rather than human psychology tricks. So tricking agents to choose one thing over the other, but obviously these tricks look nothing like context effects. And they're basically built by engineers and they're sandboxed with AI agents. So that's what I have for you today, and I'm excited for the conversation.